Welcome. In this video, we are covering everything you need to pass the Pcap, the Certified Associate in Python Programming, exam code Pcap 3103. This is the intermediate level Python Institute certification. Where the PCEP covered syntax and basic control flow, the Pcap goes deeper. Object-oriented programming, closures, decorators, generators, file processing, and advanced exception handling. This is your complete study guide. Let's go. Let's start with the exam structure. The exam code is Pcap 3103. You have 65 minutes to answer 40 questions. The passing score is 70%, 28 correct answers out of 40. The PCEP is recommended as preparation, but is not a hard prerequisite. Question formats include single choice, multiple choice, gap fill, and drag and drop code ordering. The exam is online through OpenEDG. The domain weights on the pie chart tell you where to focus. Object-oriented programming is the single largest domain at 34%, that's 13 to 14 questions. Strings and list methods, miscellaneous, which covers generators, closures and decorators, and file processing and exception handling each sit at 18%. Finally, modules and packages at 12%. OOP alone is more than a third of the exam. Invest your revision time accordingly. The comparison table shows exactly what's new versus PCEP. The PCEP covered basic syntax and types. Modules and file I/O appeared in PCEP, but only at a basic level. The PCAP goes deep. Everything in the OOP, decorators, and generators columns is new territory that the PCEP never touched. You need all of it. Modules and packages are 12% of the exam, but they underpin everything else. You can't write real Python without understanding the import system. The 4 import styles. Import math. Everything accessed with the math. Prefix, math. sqrt, math.py. Import math as m, aliases the module name for brevity. From math import sqrt, pi, brings specific names directly into the current namespace, no prefix. From math import asterisk, imports everything, but avoid this in production. It pollutes the namespace and makes it impossible to tell where a name comes from. The __name, __equals, __main idiom, is heavily tested. When Python executes a file directly, it sets the special variable __name to the string __main_. When the same file is imported as a module by another script, __name is set to the module's file name. Wrapping code inside, if __name equals __main_, ensures it only runs when the file is executed directly, your test calls, your main function, and not when the file is imported as a library. The module search diagram shows the 5-step lookup. First, Python checks sys.modules, the cache of already imported modules. If found, the cached version is returned immediately. If not, it searches the current directory, then Python path environment variable directories, then the standard library, then site packages, where pip installs third-party packages. If nothing matches, you get a module not found error. Package structure. A directory becomes a package when it contains an __init__.py file. The __init__.py runs when the package is imported. Use it to expose a clean public API with from.module import something. The __all__ list controls what gets exported when someone does. From my package import asterisk, only names and __all__ are included. Relative imports. From. Import utils means from the same package. From import other means from the parent package. Relative imports only work inside packages, never in top-level scripts. Next. Strings are 18% of the exam, and string method questions are among the most fill-in-the-blank heavy questions you'll face. Work through the method reference systematically. Case and alignment. Upper, lower, strip, removes whitespace by default. Pass a string argument to strip specific characters. Center 30, pads with dashes to width 30. Just and richest. Left and right justify. Z-fill pads with leading zeros. Search methods. Critical distinction. Find. Returns -1 if the substring is not found. Index raises a value error. The exam will test which you use and what happens when the substring is missing. rfind and rindex search from the right. Count counts non-overlapping occurrences. Replace with the optional third argument limits the number of replacements. Split with no argument splits on any whitespace and removes empty strings. This is different from split with an explicit space, which preserves empty strings between consecutive spaces. Join is the reverse. Call it on a separator string and pass the list. Join A, B, C. Advanced F-string formatting. Know every specifier. Point 4F is 4 decimal places. Balance. Point 2F adds thousands comma separators. 42. 08B is binary padded to 8 digits. 255 #010X is hex, with the 0x prefix in a field of 10 total characters. R forces repara, S forces str. The pi equals 0.2f debug shorthand, prints both the variable name and its value. And 0.2% formats as a percentage, 0.1234 becomes 12.34%. Beat ord, A, returns 65, the Unicode code point. CHR, 65, returns A. S.encode, UTF-8, converts a string to bytes. Know these for the exam. They appear in questions about character manipulation and encoding. Next. OOP is 34% of the PCAP. This slide establishes the foundational concepts. Everything else in the OOP domain builds on top of it. Class dog defines the class. The body contains class attributes, species and count, defined directly in the class body, shared by all instances. The __init___ method is the constructor. Python calls it automatically when you create an instance with dog, rex, 3, GSD. The self parameter refers to the specific instance being created. Instance attributes are set inside __init__ using self.name equals name. Every dog object has its own name, age, and breed. The class attribute dog.count is accessed and modified via the class name dog.count plus equals 1. If you accessed it via self.count plus equals 1, Python would create a new instance attribute that shadows the class attribute rather than modifying the shared one. Beat instance methods take self as the first parameter. Python passes the instance automatically. When you call rex.bark, Python translates it to dog.bark, rex, under the hood. Beat the dunder methods are the first key OOP concept. __str___ is called when you pass an object to str or print. It should return a human-readable string. __repr is called by repr and by the REPL. It should return an unambiguous representation that ideally could be used to recreate the object. __len is called by len. __init__ is the constructor. These special double underscore methods are how you make your objects integrate naturally with Python's built-in functions and syntax. Beat the 3 method types. Instance methods, defined normally, take self, access instance, and class data. Class methods, decorated with @class method, take CLS instead of self, access the class but not instance data. Use class methods for alternative constructors. Circle.from_diameter 10 creates a circle from a diameter instead of a radius. Static methods, decorated with @static method, take neither self nor CLS. They're logically related to the class, but don't need access to any class or instance data. Utility functions that belong in the class namespace. Next. Inheritance is the mechanism by which one class acquires the attributes and methods of another. It models relationships. A dog is an animal. A golden retriever is a dog. Class dog. Animal. The parent class name goes in parentheses. In dog__init__, the first thing we do is call super. __init__. Name, sound equals woof. Super. Returns a proxy object that delegates method calls to the parent class following the method resolution order. This ensures the parent's __init__ runs and sets up the name and sound attributes correctly. Beat method overriding. Dog defines its own speak method. When Python looks up rex.speak, it finds dog.speak first and calls that instead of animal.speak. Inside the override, superSpeak explicitly calls the parent version, so the dog speak message includes the animal speak message as its base. This pattern, extend, don't replace entirely, is the Pythonic approach. Beat isInstance and isSubclass, 2 critical functions. IsInstance, Goldie dog, returns true. IsInstance, Goldie, animal, also returns true, because golden retriever inherits from dog, which inherits from animal. IsInstance checks the entire inheritance chain. Type, Goldie, == animal, would return false. Type, returns the exact class, not the hierarchy. Always prefer isInstance in real code. Beat multiple inheritance in MRO Python allows a class to inherit from multiple parents. Class DBC inherits from both. When d.hello is called, Python must decide which parent's hello runs. It uses C3 linearization, the method resolution order. Check d__MRO__. It's a tuple showing the exact lookup order. D, then B, then C, then A, then object. The search goes left to right, depth first, with the constraint that no class appears before all classes that depend on it. B comes before C, because it's listed first in D of BC. Beat super, and multiple inheritance follows the MRO, not necessarily the single named parent. The example with W, Y, Z shows that calling super method in Y doesn't go to X directly. it goes to Z next, following the MRO. This cooperative multiple inheritance pattern ensures every class in the hierarchy gets to run. Ext. Encapsulation is the practice of controlling access to an object's internal state. Python doesn't enforce access control at the language level. Instead, it uses naming conventions. A single leading underscore balance signals protected. It's a convention meaning intended for internal use. Use it outside the class if you must, but you're on your own. A double leading underscore pin triggers name mangling. Python rewrites it to underscore bank account underscore pin in the objects underscore dict underscore. This prevents accidental access and name collisions in subclasses. You can still access it as ACC underscore bank account underscore pin if you really need to. Python doesn't enforce true privacy, but the convention is respected. Beat properties are the Pythonic way to add computed or validated attributes while keeping the simple .access syntax. The @property decorator turns a method into a getter. Accessing ACC balance calls the balance method and returns the value. No parentheses needed from the caller's perspective. The @balance.setter decorator defines what happens when you assign to ACC balance equals 1500. You can validate the new value before storing it. The @balance.deleter handles del ACC.balance. This is the key insight. From outside the class, ACC balance and ACC balance equals 1500 look like plain attribute access. But internally, validation logic runs. If you start with a plain attribute and later need validation, you can upgrade it to a property without changing any code that uses the class. The interface stays the same. The dunder method slide for vector shows operator overloading. __add__ is called when you write v1 plus v2. __mul__ handles v1 *3. __rmul__ handles 3 *v1. The reflected operation, called when the left operand doesn't know how to multiply. __neg__ handles unary mash of v1. __eq__ defines equality. Note, it returns not implemented when the other operand isn't a vector, which lets Python try the reverse comparison. ___ is called by ab_is_v. __bool__ is called in Boolean context, if v. Learn which operator triggers which dunder method. The exam tests this directly. Ext. Polymorphism means many forms, the same operation working differently on different types. Python's approach is duck typing. If it has a speak method, I can call speak on it, regardless of what class it belongs to. The make_sounds function takes a list of animals. It doesn't care whether each item is a cat, dog, or parrot. It just calls .speak on each. As long as the object has a speak method, it works. There's no explicit interface declaration or inheritance required. This is significantly more flexible than the inheritance-based polymorphism you see in Java or C++. The built-in len function is polymorphism in action. It calls __len on whatever object you pass. Len, hello, calls the strings __len Len, 1, 2, 3, calls the lists __len Same function name, different behavior per type, because each type defines its own __len Beat abstract base classes from the ABC module. Class shape, ABC, inherit from ABC. Methods decorated with @abstract method are the contract. Any concrete subclass must implement them, or Python raises a type error when you try to instantiate the subclass. Attempting to instantiate shape directly raises type error. Can't instantiate abstract class shape with abstract methods area, perimeter. Beat abstract men. The key power of ABCs is enforced interface design. Rectangle and circle both implement area and perimeter, so they instantiate fine. But if you forgot to implement area in rectangle, Python would catch it at instantiation time, not silently later when you call the missing method. Concrete methods on the ABC like describe are inherited by all subclasses. Subclasses get the shared behavior for free without having to override it. Two critical design concepts: composition versus inheritance, and memory-efficient class design. Inheritance models an is-a relationship. Electric car, vehicle. An electric car is a vehicle. This is correct use of inheritance. Composition models a has-a relationship. A car has an engine and has a transmission. The engine and transmission are separate objects stored as instance attributes. Self.engine equals engine, HP, fuel. The car delegates to them. Self.engine.start. Beat, the rule of thumb. Prefer composition over deep inheritance hierarchies. Inheritance creates tight coupling. Changes to the parent affect all children. Composition is more flexible. You can swap out the engine implementation without touching the car class. Beat __slots __ replaces the default underscore underscore dict underscore underscore storage, with a fixed size C-level array. Normally, every Python object stores its attributes in a underscore underscore dict underscore underscore dictionary, flexible, but memory heavy. With underscore underscore slots underscore underscore equals xy, those are the only allowed attributes. Attempting to set any other attribute raises attribute error. Objects with underscore underscore slots underscore underscore use significantly less memory and have faster attribute access, important when you're creating millions of instances. Beat at data class, the Python 3.7 decorator that auto-generates underscore underscore init underscore 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 repr underscore underscore and underscore underscore eq underscore underscore based on class annotations. Field, default underscore factory equals list, creates a fresh list for each instance, solving the mutable default argument problem automatically. Underscore underscore post underscore init underscore underscore runs after the generated underscore underscore init underscore underscore completes. Use it for validation. Note that at data class generates underscore underscore eq underscore underscore, which sets underscore underscore hash underscore underscore to none by default. Use at data class, frozen equals true, for immutable, hashable data classes. Ext. Closures and decorators together are 18% of the exam, one of the most conceptually interesting sections. A closure is a function that captures and remembers variables from its enclosing scope, even after that scope has finished executing. Make underscore multiplier 2 creates a local variable factor equals 2, then defines and returns the inner multiplier function. When make underscore multiplier returns, its local scope is gone, except that the multiplier function holds a reference to factor through its closure. Calling double 5 later still has access to factor equals 2. You can inspect a closure with underscore underscore closure underscore underscore. It's a tuple of cell objects. Each cell has a cell underscore contents attribute that holds the captured variable's value. Double underscore underscore closure underscore underscore vader_cell underscore contents returns 2. Beat, the non-local keyword, lets an inner function modify a variable in its enclosing function scope, as opposed to just reading it. Without non-local, assigning to count inside counter would create a new local variable, shadowing the outer one. With non-local count, the assignment modifies the enclosing count directly. This is how you build stateful closures, counters, accumulators, lazy initializers. Beat decorators are syntactic sugar for the higher order function pattern. At timer above def add is exactly equivalent to writing add equals timer add after the definition. The decorator replaces the function with the wrapper function. The wrapper adds timing logic before and after calling the original function through func, bargs, cacworgs. Beat at functools.wraps, func, inside the decorator's wrapper function is not optional. It copies underscore underscore name, underscore underscore, underscore underscore, underscore underscore, underscore underscore, underscore underscore annotations underscore underscore, and other metadata from the original function to the wrapper. Without it, add, underscore underscore name, underscore underscore returns, wrapper and add, underscore underscore doc, underscore underscore returns, none. This breaks documentation, debugging, and other tools that rely on function metadata. Beat, stacked decorators at timer above at logger, means add, equals timer, logger, add. The bottom decorator is applied first. So the call order when add is called is, timer's wrapper right pointing arrow, logger's wrapper right pointing arrow, original add. Decorator factories. When the decorator needs arguments, you add one more level of nesting. At repeat 3, calls repeat 3, which returns the actual decorator. The decorator then wraps the function as usual. Generators and iterators are another 18% topic, and one that many Python programmers use without fully understanding. The iterator protocol requires two methods, underscore underscore iter, underscore underscore returns the iterator object itself, and underscore underscore next underscore underscore returns the next value, or raises stop iteration when exhausted. The for loop calls iter, on the iterable to get an iterator, then calls next, on that iterator repeatedly, until stop iteration is raised. Beat, an important distinction, iterable versus iterator. A list is iterable. It has underscore underscore iter underscore underscore. But it's not an iterator. It doesn't have underscore underscore next underscore underscore. Calling iter, lst, creates a list iterator object, which has both. A file object is an iterator. A generator is an iterator. Strings, dicts, sets, and tuples are iterables but not iterators, until you call iter on them. Beat, generator functions use yield instead of return. When Python encounters yield a, it suspends the function's execution, returns a to the caller, and preserves the function's entire local state, all variables, the instruction pointer, everything. When next is called again, execution resumes immediately after the yield statement. This suspension and resumption is what makes generators memory efficient for large sequences. The Fibonacci underscore general example, yield a pauses the function and sends a to the caller. The caller gets one value at a time. The generator doesn't compute the entire sequence up front. It computes one value, yields it, waits, computes the next, yields it, and so on. Beat yield from delegates iteration to a sub-generator, or sub-iterable. Yield from it is equivalent to 4 item in it, yield item, but more efficient and cleaner. It also passes through send, values and throw, exceptions to the sub-generator, important for coroutines. Beat, the send, method. This is how you send values back into a running generator. Yield total, both yields the current total, and receives the next value sent in. Call next, ACC first, to prime the generator, advance it to the first yield. Then, ACC send 10, resumes execution, assigns 10 to value, and runs until the next yield. This coroutine style communication is powerful for data pipelines. Beat, memory comparison. A generator expression of 10,000 squares uses 104 bytes. The equivalent list uses nearly 87 kilobytes. When you only need to iterate once, always use a generator. We covered basic exception handling in the PCEP. The PCAP goes deeper. Exception chaining, context managers for exceptions, custom exception hierarchies, and the full base exception tree. Exception chaining, with from raise runtime error message, from sets runtime error, __cause, ___ equals e. When the traceback prints, Python shows you both exceptions with a, the above exception was the direct cause of the following exception message. This preserves the complete error chain. You can see both the original value error from parsing and the higher level runtime error that resulted. Without from e, the chain is still captured in ___ context ___, but the message says during handling of the above exception, rather than direct cause. Beat, context lib.suppress, a clean way to intentionally ignore specific exceptions. With suppress, file not found error, if any code inside the block raises file not found error, it's silently ignored. The block just exits cleanly. This is cleaner than a try, except that does nothing in the except block. Beat, custom exception hierarchies. The app error base class takes a message and a code. Validation error extends it, adds a field attribute, and builds a formatted message. Database error and connection error extend the hierarchy further. The power, except app error catches validation error, database error, and connection error all at once, because they all inherit from app error. You can apply broad handling at the base level and specific handling at the leaf level. The exception hierarchy diagram. Understand the tree. Base exception is the root. Everything inherits from it. System exit, keyboard interrupt, and generator exit sit directly under base exception and are intentionally outside exception. This is why except exception doesn't catch Control-C or sys.exit. Under exception, the two most important subtrees for the exam: arithmetic error, covering zero division error and overflow error, and lookup error, covering index error and key error. OS error covers file and operating system errors. File not found error and permission error are both OS error subclasses. Next, file processing is part of the 18% file and exceptions domain. The exam tests both text and binary I/O, the full set of file modes, and working with structured formats like CSV and JSON. Open, two key parameters, the path and the mode. R reads, raises file not found error if missing. W writes, creates the file if it doesn't exist, truncates it to 0 bytes if it does. A appends, creates if missing, adds to the end if present. X exclusive create, raises file exists error if the file already exists. Add B to any mode for binary RB, WB. Always specify encoding equals UTF-8 for text files to avoid platform-dependent encoding problems. Beat file reading methods. F.read returns the entire file as one string. F.readline returns one line including the new line character. F.readlines returns a list where each element is a line including the new line. Iterating the file object directly, for line in F, is the most memory efficient for large files. Beat F.tell returns the current byte position. F.seek, offset whence, repositions. Whence equals 0 is absolute from the start. Whence equals 1 is relative to current position. Whence equals 2 is relative to the end. F.seek, -5 2, positions 5 bytes before the end. Beat CSV, CSV reader gives you a list per row. CSV dict reader gives you a dict per row, with column headers as keys. New line equals, in open, is required for CSV writer. The CSV module handles new lines internally, and needs clean access to the byte stream. Beat JSON. JSON.dumps, data, converts a Python dict to a JSON string. JSON.loads, string, parses a JSON string back to a dict. JSON.dump, data, file, writes directly to a file. JSON.load file, reads from a file. The indent parameter makes the output human readable. JSON supports strings, numbers, lists, dicts, booleans, and null. Python tuples become JSON arrays. Python dicts become JSON objects. Beat OS path, know the key functions. Exists, file, or directory present. Join, platform safe path building. Base name, file name from a path. Dir name, directory component. Splitext, splits into name and extension tuple. Extet. This slide bridges the comprehensions from the PCEP with the functional programming tools that appear in the PCAP miscellaneous domain. The nested comprehension for matrix multiplication shows how far comprehensions can go. The outermost for I iterates rows. The middle for J iterates columns. The inner sum is a generator expression that computes one cell. Read nested comprehensions outside in. The last for clause is the fastest changing loop, just like nested for loops. Beat conditional expression in comprehension. If x greater than equals 0, else negative x for x in data. The if-else before for is a ternary expression that transforms every element choosing between two values. This is distinct from the filter if that goes after for. Both patterns appear on the exam. Beat Conniter tools, the exam's most tested standard library module after math and random. The combinatoric iterators are exam staples. Permutations, ABC2, produces all ordered arrangements of two items from ABC 6 pairs. Combinations, ABC2, produces unordered selections, 3 pairs. Combinations underscore with underscore replacement, AB2, allows repeats, AA, AB, BB. Know how many results each produces. Permutations gives NNR, combinations gives NR. Atations got R-lice, slices an infinite iterator. R-lice, counter 5, takes the first 5 from the count up forever counter. itertools.chain concatenates iterables. Chain.from underscore iterable, flattens one level of nesting. Beat functools.reduce applies a binary function cumulatively. Reduce, lambda ACC x, ACC asterisk x, 1, 2, 3, 4, 5, starts with 1, multiplies by 2 to get 2, multiplies by 3 to get 6, by 4 to get 24, by 5 to get 120. This is the left fold, classic functional programming. Functools.partial fixes some arguments of a function, creating a new function with fewer parameters. Partial, power, express equals 2, creates a square function. Partial is cleaner than a lambda when you're just fixing arguments, and more descriptive. At LRU underscore cache memoirs is a function, caches results indexed by the arguments. Recursive fib, 50, without caching recomputes millions of overlapping subproblems. With @LRU underscore cache, each unique input is computed once, and cached. fi_vib.cache underscore info shows hits, misses, and current cache size. Next. This slide goes into two of the most important advanced OOP topics, context managers and dynamic attribute access. The context manager protocol requires two methods, underscore enter underscore and underscore exit underscore. When the with statement begins, Python calls underscore enter underscore. Whatever underscore enter underscore returns is bound to the as variable. When the with block exits, normally or via exception, Python calls underscore exit underscore with 3 arguments, the exception type, exception value, and traceback. If no exception occurred, all 3 are none. Beat underscore exit underscore controls exception handling. If it returns true, the exception is suppressed. It doesn't propagate. If it returns false or none, the exception is re-raised. The example suppresses value error, but lets everything else propagate. This gives the context manager precise control over which errors it handles. Beat at context manager from context lib lets you write a context manager as a generator function with a decorator. The code before yield runs as underscore enter underscore. Whatever is yielded is the value bound to as. The code and finally runs as underscore exit underscore. The try/finally structure ensures cleanup runs even if an exception occurs. This is often more readable than writing a full class, with underscore enter underscore and underscore exit underscore. Beat underscore call underscore makes instances callable. Add5 equals adder5, and add510 calls add5 underscore call underscore 10, which returns 15. Callable, add5, returns true. This is the pattern behind function factories and callable objects that maintain state. Beat underscore get hattra underscore versus underscore get attribute underscore. The subtle but important difference. Underscore get hatter call underscore is called only when the normal attribute lookup already failed. It's the fallback. Underscore get attribute underscore is called for every attribute access, even successful ones. In the dynamic config example, underscore getAttribute intercepts access to keys that aren't real attributes and looks them up in the underscore data dictionary. Beat underscore setAttribute is called for every attribute assignment. The implementation uses a conditional name starting with underscore use super setAttribute for normal storage, while other names go into underscore data. Without the super, call for underscore names, setting self. Underscore data would recursively call underscore setAttribute forever. We covered the LEGB rule in the PCEP. The PCAP extends this with a deeper look at namespaces and first-class functions. The LEGB lookup, local, enclosing, global, built-in. The three-level example makes it concrete. Inner has its own x equals local, so it prints local. Outer has x equals enclosing, so after inner returns, it still prints enclosing. The module level x equals global is untouched, prints global. Beat globals returns a dictionary of the current module's global namespace. Locals returns a dictionary of the current local namespace. You can inspect what's in scope at any point, useful for debugging and for dynamic variable creation, though the latter is generally discouraged. Beat global keyword declares that an assignment inside a function should modify the module level variable rather than create a new local. Without global total plus equals n inside add underscore to underscore total would raise unbound local error because Python sees the assignment and treats total as local, but it hasn't been initialized locally. Beat first-class functions. Functions in Python are objects. You can store them in lists, pass them as arguments, return them from functions, and add custom attributes to them. The transforms equals square, cube, negate. Example, no parentheses, so these are the function objects themselves, not their return values. For fn in transforms, fn5 calls each in turn. Beat compose, fg, returns a new function h, where h of x equals f of g of x, function composition. Square underscore, then underscore negate, equals compose, negate, square, calling it with 4 first squares to get 16, then negates to get minus 16. Function attributes, underscore name, underscore is the function's name as a string. Doc underscore is the doc string. Underscore annotations, underscore is a dict of the type hints. Functions can even have custom attributes set on them. Greet.call underscore count equals 0, adds a call underscore count attribute to the function object. This is an obscure, but valid Python feature that occasionally appears in advanced exam questions. Ext. Every item on this slide is a pattern that reliably trips up PCAP candidates. Go through each one carefully. Mutable class attribute trap, the most devastating OOP mistake. Class student. Grades equals, this grades list is a class attribute shared by every student instance. When alice.add underscore grade 90 appends to self.grades, it's modifying the class level list because there's no instance attribute named grades to shadow it. Bob.grades then shows 90, even though Bob never received a grade. The fix. Always initialize mutable data in underscore init as self.grades equals creating a fresh list for each instance. Beat super. In Python 3, no arguments needed. Super init x just works. In Python 2 you had to write super, child, self, init x. If the exam shows Python 2 style super, it's wrong for Python 3. Beat is instance versus type. Type B equals A checks for exact type match. Is instance, BA, checks whether B is an instance of A or any subclass of A. For polymorphic code, is instance is almost always what you want. Type is for when you need to distinguish between a parent class and its children. Beat EQ kills, hash, When you define EQ on a class, Python automatically sets hash, equals none, making instances unhashable. You can no longer use them as dictionary keys, or put them in sets. To fix this, also define hash, explicitly. Typically return hash, self.x, self.y, or use at data class, frozen equals true, to get both EQ and hash, automatically. Beat generator exhaustion. A generator can only be iterated once. After all values are yielded, it's exhausted. List, gen, empties it. Calling list, gen, again returns. To iterate again, call the generator function again to create a fresh generator object. This is a common source of subtle bugs, passing the same generator to two different functions, and wondering why the second one gets nothing. Beat, missing at functools.wraps. A decorator without, at functools.wraps replaces the decorated functions __name __ with wrapper, and wipes its __doc__. This breaks documentation tools, stack traces, and any code that inspects function metadata. The exam explicitly tests whether at functools.wraps is required. Return in a generator. Return done inside a generator function does not return the string to the caller normally. It raises stop iteration with the string as its value. The value attribute of the stop iteration exception holds it. Generator return values are typically accessed via yield from, which captures them in the subgenerator delegation. Next, let's lock in strategy for exam day. The mind map shows the 5 domains and what's inside each. OP at 34%, classes, inheritance, MRO, encapsulation, properties, dunder methods, abstract classes, and composition. Strings at 18%, every method, fstring formatting, ord, and chr. Miscellaneous at 18%, closures, decorators with functools.wraps, generators and yield, the iterator protocol, itertools and functools. Files and exceptions at 18%, open modes, encoding, CSV, JSON, OS path, the exception hierarchy, custom exceptions, and context managers. Modules at 12%, import styles, init all relative imports, and the SYS path search order. Beat, the reference table. These are the rules with zero tolerance for mistakes on the exam. MRO, left to right depth, first C3, check class name, MRO to verify. Super, follows MRO, not the named parent directly. Properties, getter is at property, setter is at name.setter, deleter is at name.deleter. Abstract class, inherit ABC, decorate abstract methods, never instantiate directly. Mutable class attributes, never def init self, items equals, and never grades equals, at class level for per instance data. Beat generator rules, after stop iteration, the generator is exhausted, always create a new one. At functools.wraps is required, every decorator, no exceptions. Yield from delegates cleanly, to subgenerators. Defining EQ, sets, hash, to none. Define both or use at data class, frozen equals true. CSV, always new line equals, in open. Relative imports, only inside packages, start with a dot. Beat exam format reminder, 40 questions, 65 minutes. OOP alone is 13 to 14 questions. The gap fill and drag and drop question types require you to know exact syntax, not just concepts. Practice writing code from memory, not just reading it. Next. The mind map shows the complete PCAP skill tree. 8 branches covering OOP, functional programming, data, files, exceptions, and modules. 10 rules for exam day. Click Rule 1. OOP is 34%. Most of your revision time should go here. Know MRO, super, properties, and dunder methods by heart. Click Rule 2. Super. Follows the MRO, not the named class directly. In multiple inheritance, trace MRO to see the actual call order. Click Rule 3. Mutable class attributes are shared. Always initialize mutable instance data, lists, dicts, inside init with self.data equals bar pro. Define hash whenever you define EQ equals true, frozen equals true, to get both automatically. Click Rule 5, at functools.wraps is required on every decorator. It preserves name and doc . Click Rule 6, generators are exhaustible. After stop iteration, the generator is empty. Call the generator function again to get a fresh one. Click Rule 7, yield from delegates to a sub-iterator, cleaner and more powerful than a forwarding loop. Click Rule 8, at abstract method, prevents instantiation. All abstract methods must be implemented in concrete subclasses. Click Rule 9, relative imports only work inside packages. From a top-level script, from. Import X raises import error. Click Rule 10, context manager exit returns true to suppress exceptions, false or none to re-raise. Use context manager for generator-based context managers. And that is the complete PCAP study guide. All 5 domains, every critical concept, and the traps that catch candidates by surprise. Build projects. Write a file processor. Design a small class hierarchy. Write decorators and generators from scratch. Read the error messages. They tell you exactly what went wrong. If this video helped, please like and subscribe for more Python and certification content. Good luck on your PCAP. See you in the next one.